Another very useful function that works on arrays is the reduce function. And the purpose of this function is to work on each element of the array, but finally returning a single value of computation. So we say we have reduced an array to some single value of computation. But in what sense? Let's understand with the help of an example. Now, this is slightly difficult to get initially, so be patient and listen carefully. Let's say that given a list, we want to find the sum of all the elements of that list. So, just like the filter and map functions, the reduce function also takes a callback function as an argument, but its structure is a little different than what it was in the previous cases. In case of reduce, the callback function is like this. It takes 4 parameters: the previous value of computation, the current element of the array, the current index of the array, and the array on which the reduce function is working. So the additional parameter compared to the earlier callback functions is the previous computation. So let's understand each of those. This first parameter holds the value that was returned in the last invocation of the callback function, or the initial value if supplied. Just bear with me a little, it will be clear when we take an example. The second parameter takes the current element being processed in the array. The index is the index of the current element being processed, and array is the array on which the reduce function was called. Alright? Let me first use the reduce function to compute the sum of the numbers in an array and then explain what is going on. So let me write this array of numbers, then call reduce on it, and then pass a callback function to it. And here we will just pass an anonymous function. And we can optionally pass an initial value to the reduce function as the other argument. Let's pass 0 for that. Now inside the body of this function, we will return previous plus current, alright? And I'll explain why in a second. If we execute this code, we get the sum of the numbers in the array, alright? Let's understand now what's going on. When the execution starts for the given array, the current value that is passed to the callback function is the first element of the array, which is 3. Also, the index value is 0 because the current element is the first element and the index is the index value of the current element. The array is of course the same array on which the reduce function is called. What about the initial value? Well, we pass the initial value as 0, right? And what about previous? Well, the first time the callback function is called, previous is initialized to the initial value, so its value is also 0. Now the callback function returns some value, which is previous plus current, so the first time it returns a value of 3. The next time when the reduce function is called, previous has a value which was returned by the callback function in the last call, which was 3. So previous has a value of 3. Current is the next element in the array, which is 4. Current index is 1, which is the index of the current element, and array is again the same array. Again, the function returns previous plus current, which is 7. So the previous value passed to the callback function this time is 7, which is what was returned from the last call. The current element now is 6 and so on. And this time the callback function returns 13, right? Which will be passed as previous in the next call to the callback function. And this continues until the reduce function reaches the last element, such that now the previous value is 20, the current element is 9 and so on. And the reduce function returns the value that is returned by the callback function, which is 29, and there are no more elements in the array to go to. For the callback function, if we don't make use of the index and array elements, we need not take those as parameters, in which case they will be treated as undefined. So we could have written the callback function like this, just taking the previous and current values. The reduce function also takes initial value as other parameter apart from the callback function, and this parameter is optional. If we don't pass any argument for initial value, it will be undefined. But there will be a little change in the previous and current values the first time the reduce function is called. Let's see that graphically. The first time reduce function is called without the initial value, the previous parameter is assigned the value of the first element. The current parameter is assigned a value of the second element of the array. Alright? The subsequent calls to the callback function remain the same as we saw earlier. Let's use the reduce function to find the sum of n natural numbers. We can directly use the formula, which is of course better, but let's not do that. Rather, let's find it by using the reduce function. If we have to use the reduce function to find the sum of n natural numbers, then we should somehow have an array of numbers from 1 to n, right? Because then we can apply the reduce function on that array. So let's start with writing this function sum underscore natural underscore numbers and pass n as argument. And inside this we need to somehow get an array of numbers from 1 to n. But before that, let's return 0 and hit enter, so that we will change the function definition later. Now we write another function, let's call it range, which takes 3 arguments, start, end and step. So this function will generate an array of numbers starting from start, going all the way up to end, using the step to increment the numbers. And the implementation is quite easy. We create an empty array first and then push the numbers into the array beginning from start and then increasing by the step size until we cross end. Okay? And then we return this array. Now let's turn our attention to the sum natural numbers function. This takes an argument n. So here we first create an array of numbers from 1 to n and then use reduce, just like we did earlier, to find the sum of numbers from this array. So when you use functional style of programming, you should design your program in terms of data transformations. You typically start with some initial set of data, then keep generating new sets by applying functions until you reach your desired set of data. Alright? And this may take a little getting used to, so don't worry if you struggle with it initially.